Hello my dear students, welcome back to the session. Dear students, last class we have discussed problems on application of differential equations, and in one of the last classes or previous classes I have explained you how to find the time response of a particular system or a particular network. Okay, we divided the networks into two categories. I hope you remember that. Okay, the first category of the network is what? The first type of network is what? A network is of first order type, and it is excited by what? Step input. Okay, a step response based first order network which can be solved by a formula. What is that formula? X of t is equal to x of infinity minus x of infinity minus x of 0 plus of e power minus t by tau. Yes or no, all of you? Okay. Well, the second category of the networks are other than the first type. What does it mean? It might be a first order network but excited by non-step input, or sometimes the step input but with shifting functions. Second category is what? Higher order networks may be excited by a step input or non-step input. Understand all of you? Okay. So this category of the networks are solved by, I explained you clearly, only by using the application of Laplace transformations. And in that, we are going to apply S-domain equivalent circuit approach. Okay, S-domain equivalent circuit approach. So before we discussed S-domain equivalent circuit approach, we should also have a minimum knowledge in what are the properties of the Laplace transformation and what is the definition of Laplace transformation. You have already learnt in the mathematics class, no doubt, but a quick recap of all those properties. Same time, the important transformations also we will see. Understand all of you? Okay. So just I have written on the board here clearly. Okay. First, I deal with important properties of Laplace transformations. Okay. First, I deal with important properties of Laplace transformations. Okay. So if you go through it one after other. Okay. First one is what? Definition. What is the definition of a Laplace transformation? Laplace transformation of f of t, which is of course nothing but f of s, is equal to integration 0 minus to infinity e power minus st f of t dt. This is a fundamental definition of the Laplace transformation of any particular function given. Okay, where s is called complex frequency. S are all of you. S is what? Actually complex frequency, which has got some real part and imaginary part, of course. Okay, S is called complex frequency, we can say. Okay. Now next one is what? Actually here the linearity. What is the linearity actually here? A1 f1 of t plus a2 f2 of t, Laplace transformation of, will certainly give you, okay, a1 f1 of s plus a2 f2 of s. Okay, so this is one. And scaling. What do you mean by scaling? If say f of at, t is multiplied with a, then the result will become 1 by a f of s by a. Okay, this is another property. Time shift, which is very, very important, time shift. Okay, that is f of t minus a into u of t minus a is equal to e power minus as f of s. Okay, then frequency shift, Laplace transformation of e power minus at f of t is equal to f of s plus a. Okay, and this time differentiation, the sixth important property is time differentiation, which we use very frequently in our solving the networks. Okay, and which is very important in deriving even the equivalent of S-domain equivalent of an element, RLC elements. Okay, we can see here Laplace transformation of d power n f of t by dt power n, s power n f of s minus s power n minus 1 f of 0 minus s power n minus 2 first derivative of the function f, but 0 minus condition. We are supposed to use 0 minus conditions here, and so on so forth. S power 0 d power n minus 1 f of 0 minus by dt power n minus 1. In most of the textbooks of networks, you can see people indicate 0 plus. 0 plus they indicate, but be careful. I'm telling you here, better use 0 minus conditions, because there are certain cases There are certain cases where 0 plus conditions may not be same as 0 minus conditions. There are some special problems involved in solving the networks. Understand all of you, okay? That is why better you remember 0 minus conditions instead of 0 plus conditions in this particular formula. Understand all of you, okay? Because there are some special cases where 0 plus conditions may not be same as 0 minus conditions. We know that very well because when current through the capacitor is infinite, that is nothing but ideal impulse, then voltage across the capacitor may change instantaneously. The Vc of 0 plus is not equal to what? Vc of 0 minus. Similarly for inductor also, IL of 0 plus is not equal to IL of 0 minus in case if the voltage across the inductor is found to be infinite, that is nothing but ideal impulse. That is why, okay, that is why to solve any kind of problem, to avoid the controversies, to avoid the confusions and all, okay, I generally prefer 0 minus conditions rather than 0 plus conditions. Okay, so remember always it is 0 minus conditions. Now time integration, okay, time differentiation, time integration. Okay, L of integral f of t dt. Most of the times we remember only this particular part. Usually people remember only this particular part. Okay, but you should also remember the 0 minus conditions, integral f of 0 minus dt by, yes, this part is very, very important, I'm telling you. Okay, because in solving our networks, 0 minus conditions are very, very important here. Okay, next, frequency differentiation, nothing but L of t power n f of t. Okay, nothing but minus 1 power n d power n f of s by ds power n. Okay, so these are all very important to be fed. I'm telling you, you can't really search for the formulas. You can't really do investigation in the exam. It's not possible. You don't have that much time, I'm telling you. So you have to feed it permanently in your memory. Okay. Then frequency integration, L of Laplace transformation of f of t by t is equal to integration s to infinity f of s ds. Understand all of it? Okay. So these are all very, very important. Apart from this, you can also add a few more. Initial value theorem, initial value and final value. Initial value, okay. What is the initial value? F of 0 plus is equal to limit t tends to 0, limit t tends to 0, f of t, or else limit s tends to infinity, s into f of s. 11th one is final value. Final value f of infinity, which is nothing but limit t tends to infinity f of t, which is equal to limit s tends to 0 s into f of s. You understand all of it? So this is how you can deal with the properties. Please note down quickly all the properties. But I think all of you might be knowing the final value is applicable only for stable systems. Applicable for stable systems. Okay? Stable systems for stable networks. Stable system means what? Stable and unstable systems. What are the difference between these two? All the poles, okay, all the poles of the system are located in the left half of the S-plane. Yes or no, all of you, okay? Or else the differential polynomial, whatever you are obtaining, will have a same sign. All are having negative or all are having positive. The coefficients I'm talking about, the coefficients of the differential polynomial or the coefficients of the characteristic equation, all are having, either positive sign or negative sign. Only one sign should be there. Okay. So stable systems only it is applicable. You can't substitute simply t tends to infinity and find the final value. It's not possible. You have to verify first of all the system is stable or not. Okay. So please note down quickly all these important properties. One should be expertise in all this. I mean, one should really remember. Okay, I guess you have noted down this part, and please note down that. Meanwhile, I just note here. Okay, so list of transformation, important list of transformation. Let us have a look at now. List of transformations. List of transformations. The first one is, okay, I think might be knowing the time domain and S domain here. Okay, time domain and S domain. What is the time domain? Actually, if we take first one is impulse. What is this? 1. Yes or no? If you take unit step or step input, step function, that is R of t is equal to capital U of t. Then what do you get here? R by S. Yes or no? Third one is a ramp function. R of t is equal to R t, let us say, U of t. Then what do you get? R by S square. Fourth one is parabolic function. R of t is equal to R t square by 2 U of t. Then what do you get here? R by S cube. Is that all of you okay? Fifth one is, say you got t power n, e power minus at, then you got n factorial by s plus a whole power n plus 1. And all of you must remember all this, okay? One should really have, okay, complete, you have to memorize all these things, okay? Oh, let me erase this one, okay? Please note down quickly. You have already studied all these things in your mathematics class, but still a quick recap, because when we solve the problems, we should not get any doubts on this list of transformations, properties. You should not have any doubt, okay? So that is why I'm discussing once again. Right. Sine omega t. Sixth one is sine omega t. Omega by s square plus omega square. Cos omega t. S by s square plus omega square. Eighth one, sine omega t plus theta. Omega by, okay, not omega, but you get here s sine theta plus omega cos theta by s square plus omega square. Similarly, the ninth one is cos omega t plus theta will give you s cos theta minus omega sin theta by s square plus omega square. Understand? Okay. So if you substitute theta is equal to 0, what do you get? Theta is equal to 0 means omega by what do you get here? S square plus omega square. Substitute 0 here. S cos theta is nothing but S omega sine theta, theta becomes 0, s by s square plus omega. The same thing you are going to get here. Okay, so note down please. 10th one. Similarly, time domain e power minus at sine omega t will give you omega by s plus a whole square plus omega square. 11th one, e power minus at cos omega t s plus a by s plus a whole square plus omega square. So like this you can give all list of transformation, very simple. Yeah, you can also take one more here, 12th one. 12th one here, time periodicity. This is very important property which we have actually not mentioned in the case of properties. You can place the same 12th one here. There also 12th property you can take. Okay, we have already listed out the properties, right? You can place this one there. Understand all of you, okay? I think 13th property or 12th property, you can place this one in the list. Otherwise, you can keep as it is in the list of transformations. Time periodicity means what? There is a periodic waveform, sine wave, cos wave, let us say triangular wave, sawtooth waveform, trapezoidal waveform, or step, function or square wave, let us say. Otherwise, they're all getting repeated continuously. Periodic waveform, we can call them. In that case, the transformation becomes the f of t plus nt, Laplace transformation of f of s by 1 minus e power st. Okay, so please note down this. This is very, very important. This is minus ts, okay? This is minus, not plus, okay? This is minus. F of s by 1 minus e power minus ts or st. Okay, ts, st both are same, but usually people remember minus ts. Yeah, okay? So I think all of you noted down this. You are, I think, aware of how to find the inverse Laplace transformation, okay, using partial fractions, method of residues. Yes or no, all of you, okay? So you must be good at all those things. You must be good at all those things. You should not get any doubt in that case, okay? All of you. Yeah. So let me start with, the S-domain equivalent of. Now we are going to solve the networks. Using application of Laplace transformation, we are going to solve the problems. Okay. So before we solve the problems, let us also look at how do you construct the S-domain equivalent of a given network. When time domain network is given, we need to construct S-domain equivalent network, and then we need to, okay, find a solution. Getting all of you, okay? So what is the problem that we have faced actually here? The problem here is higher order networks or any network, higher order networks excited by any input, or any first order network excited by non-step input or shifting inputs. In such cases, solving the networks is very difficult using our formula. Yes or no, all of you? That is why we are approaching what? S-domain equivalent. That is nothing but using application of Laplace transformations. The one advantage with the Laplace transformation is that any problem can be solved. Any problem can be solved, no doubt in that. You give me any problem, I can solve using Laplace transform. But you give me any problem, I cannot solve using, the time domain approach or else that formula what we discussed. Okay, but the disadvantage with this particular problem, with this particular method is that you have to go for inverse Laplace transformation, that is the partial fractions. So definitely it's going to be time taking depending upon the size of the problem. The size of the problem is increasing, okay, then definitely it takes time. Okay, so one should be expertise to reduce the time. One should be expertise, or you must be expertise in finding the inverse Laplace transformation using partial fractions, using some simple shortcut techniques. Understand all of you? Okay, you might have already learnt in the case of mathematics, but still you make sure that you are really perfect in finding the residues of, the what you call partial fractions. In finding the partial fractions, if you use the method of residues, you can save a lot of time. Understand all of you? Okay, so I cannot really go into the details of how to find the residues and all those things. Will take a lot of time again otherwise, but you need to verify, because that will be helpful to you in mathematics as well as in our network theory. Getting all of you? Okay, so if you're good at differential equations, Laplace transformation, you're good at mathematics as well as the network theory. So you should be really taking care of all these things. Okay, now the method to find the time response, or step by steps, or different steps, let's say. Let me put here like this. Step-by-step procedure to find steps to determine time response using application of Laplace transformation approach. Understand all of you? Okay, using application of Laplace transformation. Okay, the first step is construct S-domain equivalent. I will tell you what is the S-domain equivalent of each element. Okay, S-domain equivalent of the given network. Okay, first you have to construct that. Second step is determine S-domain response using a KCL or KVL. Usually you can apply either KCL or KVL, or mesh analysis or node analysis. Okay, node analysis or mesh analysis, whatever it is. Okay, or both sometimes. Finally, you get a response of S-domain. Now, once you have S-domain response, okay, now you need to find time domain response. Now determine time domain response. What is the time domain response here? Time response is nothing but what? Inverse Laplace transformation of what? S response, or S domain response. Yes or no, all of you? Okay, simple, right? That's it. So you are going to follow this step-by-step approach, and this approach you are applying or you are preferring only for higher order circuits. Okay, since I told that you can apply this method to any circuits, don't attempt every circuit using this S-domain approach. Unnecessarily you are going to kill your valuable time, particularly in finding the inverse Laplace transformation will take a lot of time. You have to construct the equivalent network, that is time taking, and finding the response, putting your efforts, all of your efforts, okay, using node mesh analysis again will take a lot of time, and inverse Laplace transformation will take more and more time. Yes or no, all of you? Okay, that is why when you have other than the first category, that means second category of the problems I explained you, only in those cases you apply this step-by-step approach of this S-domain equivalent circuit approach. Understand all of you? Okay, Okay, so what is the S domain equivalence of different elements? S domain equivalence of RLC elements. RLC elements. First, let me start with the resistor. A, B, capital R, plus minus V of t, I of t, or else IR of t and VR of t. Okay. Now let us apply. Let us apply. For this, you know that VR of t is equal to R into IR of t. If you apply Laplace transformation to it, you get capital V. Okay, usually S domain capital letters, time domain lowercase letters. VR of S is equal to capital R into IR of S. That is why the S domain equivalent of resistor will also be remain resistor only. Okay, VR of S. And this is because this equation, based on this, I am constructing the equivalent here again, IR of S. Coming now, the second one is inductor. All of you look at this, it's very, very important. IL of t, this is A, this is B, plus minus VL of t. VL of t, you know that Ohm's law, L into dIL of t by dt. Applying Laplace transformation to it, VL of S is equal to, what do you get? L into IL of S is nothing but what? S into IL of S minus IL of lowercase time, because it is an instantaneous value, 0 minus. I told you already that to use 0 minus, don't use 0 plus. I'm telling you. Okay. Usually in textbooks people write 0 plus. They write 0 plus with an assumption that voltage across the inductor is finite. But what will be the scenario if you have voltage across the inductor is infinite? That is ideal impulse. In such cases, you cannot really use this 0 plus conditions here in the formula. Okay, the problem is going to be completely wrong. That is why I'm telling you, you always remember with respect to 0 minus conditions. Right. So now you can see LS. LS is nothing but the reactance, you know very well, all of you. LS is nothing but what? S is equal to j omega L, nothing but what? Reactance. Reactance is always in ohms. Reactance into IL of S minus L into IL of 0 minus. That's it. Now this is a voltage which has two voltage components, but the polarity of this particular voltage and the polarity of this particular voltage both are opposite. That is why you are getting what? Negative sign. So keeping in mind this, I can construct an equivalent based on this particular equation. Okay, VL of S is equal to LS IL of S minus L IL 0 minus. Based on this, I construct the equivalent something like this. Look at this, all of you. What is this? LS. What is the current flowing here? IL of S. Yes or no, all of you? IL of S. Because of this current direction, what are the polarities you get? Plus minus. And what do you get here? The voltage. I'm just replacing it by a voltage source. In series. Why in series? Because the voltages are supposed to be added. Okay, in series. But the polarities of this particular voltage component and this particular voltage component are opposite. It is clearly indicated with the negative sign. Therefore, if it is plus minus, I must place minus plus L IL of 0 minus. Understand? And this is A. Now this is B. Now you're going to replace this time domain. Okay, time domain inductor is replaced by S domain inductor. So far we remembered only this part, neglecting the 0 minus conditions. But you cannot neglect all the time. You may have 0 minus conditions. You should also take them into account. Okay. If you find that IL of 0 minus and after that you find it, let us say 0, that's not a problem. You can make it 0 and finally you are left with only LS. But most of the times you may have. That is why you can't really neglect this now onwards. All of you understand this? Okay? Well, but here you know that between AB terminals there is a voltage source with a series impedance or reactance. Because this component value is how much actually here? What is the component here? Actually here, LS is nothing but ohms only, right? If this is in ohms, okay, then what will happen here? The voltage source with a series impedance can be transformed into a current source with a parallel impedance according to source transformation. So therefore, I replace it by, because the plus minus polarities are like this, because of the plus, I can replace here like the current source, okay, current source with a parallel inductor, this is LS, okay, this is A, this is B, and this is how much current actually here? IL of S. What is this current source value? L into IL of 0 minus, L into IL of 0 minus divided by, what is this? LS. L gets cancelled. Finally, you are left with what? IL of 0 minus by S. Okay, and the voltage between these 2 points, is VL of S. That's it. This is minus. So this is plus, this is minus. So the S domain equivalent of L can be replaced by a series model or a parallel model. This is a series model. Okay, some textbooks they use series model, some textbook they use parallel model. Okay, note on this, all of you. Then we'll move on to the capacitor. Note on this. Resistor, inductor, capacitor. Look at this. This is a series model. This is a parallel model. Okay. Using source transformation, series model to parallel model, how did you get it? Using source transformation, you get a parallel model. Using source transformation, you get a parallel model. Series model applies source transformation to it, you get a parallel model. Voltage source with a series impedance can be transformed into a current source with a parallel impedance. Okay. Now coming to third one, the capacitor. Say this is IC of T, A, B terminals, okay? This is plus minus VC of T. VC of T is equal to 1 by C integral IC of T dt. Applying Laplace transformation to it. So what do you get? VC of F is equal to 1 by C. Laplace transformation of integration, you already know very well. I gave you the properties, okay? Time integration, time differentiation, frequency differentiation, frequency integration, like that I gave you. So in that time integration, if you go through that, 1 by S F of S plus integral IC of 0 minus, okay, dt by S. But you know that this component is what actually here QC, because integration of current is always a charge, but charge by capacitance will give you voltage, yes or no? So 1 by CS F of S plus QC of 0 minus by C by S, nothing but 1 by CS F of S plus QC of 0 minus by C is nothing but VC of 0 minus by S. That's it. So voltage is nothing but sum of two voltages. Now once again here I take the series model, but the polarities must be same because I am getting positive sign. If this is plus minus, this should also be what? Plus minus. Definitely this is plus minus because 1 by CS. And what is the current actually here? IC of S. IC of S. Yes or no? This is A, this is B. And what is this value? VC of 0 minus by S. And this total is VC of S. This is minus sign, this is plus sign. That's it. This is a series model. Again, voltage source with a series impedance can be transformed into what? A current source with a parallel impedance according to source transformation. So let me draw now an equivalent. Let me draw an equivalent here using source transformation. Using source transformation. Now the current source direction is according to the polarities of the voltage source. You have positive here, therefore the direction of current is towards A. Okay, this is A, this is B, this is L, yeah, not inductor, right? Capacitor. Capacitor 1 by CS. What is that you had? VC of 0 minus by S divided by 1 by CS. So what do you get? SS gets cancelled, and finally C VC of 0 minus is very, very important here. Okay, this is IC of S, and you got, let us say here, the voltage. Already you had this voltage VC of S. Okay, so this is how you can derive the S domain equivalent. Sometimes in the exam is directly asking on only equivalent circuit. Simply you will give this equivalent, and he will give one unknown, all known values, and he will ask you to find. Okay, it's very simple. I mean, you have to remember it. You can't do investigation in the exam. You have to memorize and remember all these things. They must be always on your fingertips, I'm telling you. Okay? Note down that, all of you. Classroom workbook, question number 1. If IL of 0 minus is 0 is 1 ampere, sorry, minus 1 ampere. VC of 0 is 5 volt. Then find V of t. This is what the question. Okay. The network is given like this. All of you note down the classroom workbook, question number 1. This is 10 by 3 ohm, an inductor, 5 Henry, 10 U of t. This is 0.1 farad, V of t. Okay, this is I of t or IL of t is given. Okay, this is VC of t. Now, what is asking actually here? V of t is asking. Actually, this is V of 0. Okay, please note down, all of you. V of 0. This is V of t is asking. This is I of t. Yeah, please correct it. I of t, V of t. Now, let us find. First of all, whenever he is asking the time response, you must always recollect. You must always recollect there are only 2 methods you have for the time response. The first one is a formula, but which is applicable to only first order systems. Yes or no? But given network, is it a first order or second order? So that is why when the problem is given, you have to immediately realize whether the given problem comes under first category or second category. First category, if it is, then go with the formula. Second category, if it is, then go with what? S domain equivalent. Okay. So let us do that. Now, definitely you understand this problem belongs to second order, that's category 2. S domain equivalent is the only way you have to solve. But in that, you definitely require the 0 minus conditions. Okay. For that, switching operation is required. But he has not mentioned switching operation. But instead, he provided the 0 minus conditions. 0 minus 0 plus both are same as far as inductor is concerned. And as far as capacitor voltage is concerned, same conditions. Okay. So therefore, let us construct now S domain equivalent. What is the procedure? First step, S domain equivalent circuit. Second step, find the response in S domain. Then third step, apply inverse Laplace transformation and get the response in time domain. That's it. So in S domain equivalent, what is the network you get? Plus minus, resistor remain, resistor, yes or no? 10 by 3 ohm. This becomes 10 by S. Step function, 10 by S. Inductor equivalent, I hope you remember. LS, that means what? LS means what? 5S. Then what is the source based on the direction of the current given? Yes or no? Okay. Then here 1 by CS means 1 by 0.1, that means 10 by S. What about this? Plus minus. Okay. This value is minus 1 into 5. Minus 1 into 5. This value is because L into IL of 0 minus. Hope you remember that. Okay. What about this? What about this? VC of 0 minus by S. VC of 0 minus by S. What is VC of 0 minus 5? So 5 by S. Okay. And this is what actually, because this is V of t, therefore this is V of S. That's it. That means if you take this one 0, this is going to be V of S. Now apply node analysis. All are in ohms. This is in ohms. This is in ohms. All are in ohms. Voltage sources you have. Now V of S of inspection 1 by 10 by 3. 1 by 10 by 3 plus 1 by 5S plus 1 by 10 by S is equal to 10 by S by 10 by 3 plus minus 5 by 5S plus 5 by S by 10 by S. You can simplify this. You can simplify and find V of S, okay, and then find V of t by finding the inverse Laplace transformation. V of t is nothing but inverse Laplace transformation of V of S, okay, then you get the value here. So please do that quickly here, all of you. Do that quickly. Okay. So I think if you simplify all this, you may get 5S plus, okay, 40 divided by S square plus 3S plus 2. So what do you get here? 5S by, okay, you can say 5S plus 40 by S plus 1 into S plus 2. Yes or no? So A by S plus 1. I think all of you got this. B by S plus 2. The method of residues will give you inverse Laplace transformation if you want to find. So what is that A value? What is that A value? A is equal to, okay, A is equal to, you can substitute here, right? You can substitute S plus 1 into V of S. S is equal to minus 1. You have to substitute. So S plus 1 into this total, both will get cancelled. And finally minus 1, if you substitute, what do you get here? 5 into minus 1. Okay, 5 into minus 1. So 40 minus 5 will give you 35. Okay, 35 by 35. A is nothing but 35. That's it. Okay, A is nothing but what? 35. This is 35. What about B, Nana? B is nothing but, okay, B is nothing but S plus 2 into V of S. S is equal to what? Minus 2. You can substitute S is equal to minus 2. When you substitute S is equal to minus 2, this becomes minus 10. Okay. So just a minute. It's not 5. I think it is that. It is, yeah. Yes, exactly. Okay. So what you get actually here? Yes. S is equal to minus 2 if you substitute. S is equal to minus 2 if you substitute here. Then 40 minus. When you have S is equal to minus 1, 5S plus 40, S is equal to minus 2 when you substitute here, what do you get? The answer is like, 35S plus 70. Just a minute. I'll just give you an answer here. I'm just making some calculation. Yeah, S is equal to minus 2 when you substitute here. What do you get here? This is minus 2. That means what? 40 minus 10. That is nothing but 30. But already here, S is equal to minus 2. What will happen? S is equal to minus 2 means minus 2 plus 1 minus sign is there. So minus 30. That's it. So I think you understand now. Now is equal to L inverse of, what do you get here? 35 by S plus 1. S plus 1. 35 by S plus 1. And what else? Minus 30 by. Minus 30 by. This is minus 30 by S plus 2. Understand all of you? So what do you get? 35 e power minus t minus 30 e power minus 2t. That's it. This is what the solution. So this is how you are supposed to solve the problems. My dear students, we will see the remaining problems in the next class. We have some more important problems. The understanding purpose I have taken a simple example. Okay. So the problem depends on how faster you determine the inverse Laplace transformation. Using the method of residues, please check back once again, go back to your mathematics, okay, Laplace transformation, and check how do you find the residues. Okay, residues are nothing but AB are called residues. How do you find the residues using, simple